Okay. Okay, yeah, I think we should get started again. It won't take a lot of time. There's only like 6 slides left. Is it running? Great. Okay, so let me just quickly reiterate about variables, because the next slide is also about some variables. But so we can define a variable that is an integer, a container for integers. So we define it by saying int, the name, an equal sign, and an initial value. And we can set these variables again at a later point, omitting this integer thing because it was already defined. So yeah. So when defining the variable, remember the int. When just setting a new value, assigning a new value, don't know int. Okay. So the next thing we should talk about is that these integers can also be used to put like they can be used to give the reader of your program an understanding of what is actually going on. So you remember the earlier thing, this one, we just set 13 here. But 13 is actually an integer. We can make a variable that we call please find a chalk on the left. Yeah, here we go. I can make an integer variable saying int and then LED pin equals 13 and then a semicolon, and that would greatly increase the readability of my program if instead of 13 it said LED pin instead of 13. It would increase the readability, because then you would actually, reading the program, see, okay, this is an LED that is supposed to be blinking. So you can actually use variables not only to store the stuff that you actually measure, but also to store stuff that you use in your code to increase the readability. And remember that is a good idea.
So JC, where would you put that int LED pin is equal to 13?
That is for the next slide about variable scope, because scope is something that might be difficult to grasp. So variables are always defined in a scope, and a scope is defined by being between these curly braces. So if you define an integer up here in setup, it would not be accessible down here in loop, because it's in 2 distinct set of curly braces. So what do we do about that? Yes, and this is called the variable scope. It is defined within the scope. But we can instead do this to define it outside of the scope of loop and setup. So it's like in a parent scope. Does it make sense? Because it is. You can say if this is below, then this is above, because this is outside of the starting point of this curly brace. So you just, a good rule of thumb, as I wrote here, just define all your variables in the beginning of the program until you grasp this scope thing, which can be very abstract and difficult to get in the beginning. So just remember, when doing programs with variables, define them in the beginning, because then they're in what we call the global scope. So if we define an integer here, then it would be both accessible within setup, which is right now very short, and also down here in loop. So that was very quickly about scope. But don't worry if it's difficult to understand the scope thing. Just define all variables outside of both setup and loop. The next thing we're talking about is conditions. This is the if-then thing. And this is really the cornerstone of Arduino programming, because you do stuff if something is, if some value, some dependency or condition is satisfied. So you could say if we have a variable called number, and if that variable is higher than or greater than 3, then you can do something. I've just put this red. This isn't code. It's just a comment, you might, if you will. Then you could blink a LED. You could do something with some other output. You could make your LED strip flash or whatever. Then you can also make this else, which means in the other case, if number is not greater than 3, that means if it's less than or equal to 3, they can do something else. And this is maybe the most important thing to grasp in Arduino programming. Can you even read the code that's on the board? Like also this, is that readable? Legible? Okay. So the next thing is about reading sensors. This is also something that you're going to need. I can see already, I forgot a semicolon here. I'm pretty good at seeing that after having mechatronics where people forgot them all the time. So yeah, anyway. Reading sensors is also very important for you all because that's probably what you're going to do with your games. If not buttons, then sensors perhaps. So sensors are often connected to an analog input pin, as we talked about it at the pin overview. And they're read with the Arduino command called analog read. I will give you a list of commands, list of commands that work in the Arduino. I'll put it out on CampusNet. It's on the Arduino website. There's a list of all the stuff that it can do and descriptions for actual human beings what it does. So don't despair. But let's say we define with now I break the rule of thumb that I already told you about making everything in the global scope. But bear with me. Inside my loop I define a variable called sensor value, or sensor reading, and I assign it to whatever is read on pin number 2. And what was it we could do with pin number 2? Yeah, we could have put this 2 inside a variable, so we could, instead of 2, write sensor pin. But we can also just write 2 if we want to. Given that the sensor is connected to Arduino pin 2. Am I confusing you? Okay, a little bit maybe. So you can say if the sensor value is above some threshold, do something. I'm not really concerned about what you want to do, but you can do whatever that an Arduino can do. And then we have loops, and this is the last slide of the programming lecture. Loops are used. Can you read that? Maybe a little difficult. Okay. I'll try to read it aloud, and you can get the slides from CampusNet in a minute. So, loops are used when you want to do something over and over and over until some condition is met, satisfied. So that could be, you could, if you want to do something a number of times, like say you want to do something 10 times, then you could have an integer that starts at 10 and say as long or while that counter is over 0, sorry, then do this, and then remember to decrement the counter every time. But you can also just do it yeah, that's what I do here. So I set some n variable to 5. Then I say while the n is greater than 0. So it starts out being 5. So 5 is definitely greater than 0. Then it should do the blink example we had a couple of slides ago, like just high, wait, low, wait. And then it says n equals n minus 1. So it just sets n to 1 less than it was before. So, and then it goes up here again. Now n is 4. So it does, then it becomes 3 and 2 and 1. And at one point it becomes 0. And then we are down here going further in the program. And then we just delay for 5 seconds instead of just 1 and start over at loop again. So you can say loop is actually an implicit loop. It's a function that is run over and over and over again by the Arduino itself. So it's implicit. So what is the difference between if and while? we talked about the if condition. Like you can say if something is greater than, equal to, less than some other thing, then do whatever. But what is the difference between while and if? Yeah?
I guess that the while loop repeats itself until the condition is no longer true.
Exactly. That is the difference between while and if. While does whatever is inside this scope over and over and over again until this this condition is not true anymore. So until n over 0 is not true anymore. And that is the difference between while and if.
What would happen then if there stood if instead of while? What I don't get what
then you would say if n is greater than 0, and that is true because n, we just set n to be 5. If n is over 0, then it would do this, and it will set n to 4, and it would just continue. So a while does it over and over again, and if does it once.
Okay, I thought the loop is saying it do it over and over again.
That's true, but still, and that is well seen or whatever. But there will still be a difference in how the programs would work, because this one blinks with a delay of 1 second, like high, low, with 1 second intervals 5 times. Then it waits 5 seconds and starts over. If it was an if, then it would say, okay, n is high, the 5 is greater than 0. It would say high, low, high delay, low delay, set n to 0 and wait 5 seconds. If it was only an if. So if does it once, but whereas while makes sure it does it until the condition is not true anymore.
So it's kind of a loop in a loop.
Yeah, definitely. This while loop is loop. This function called loop is also a loop. So yeah. Okay, that was actually the last lecture, the last slide on the lecture. The idea was that I taught you the absolute minimum of what you needed to know in order to get started. And then I want you to formulate what you actually want to do, make some concept development, and get back to me. And then I will write some slides or make some lectures that will actually cater your needs. So you should figure out what you want to do for the rest of the day, and I will probably be here too if you want to ask questions. Formulate it and put it into a PDF file, and either send it to me or put it on CampusNet if you want to. If you want others to read it as well, and if others want to read it, then yeah, and that's it. So I have some final notes. This is the last slide. You will run into problems, and I know that this subject is difficult to grasp until you actually work with it. So my suggestion is just go on with it. Ignore how you think you don't know anything about it. Just get your hands dirty. And if you get errors, Google the error message, or Google what you're actually trying to do. If you're trying to control a motor, then Google controlling a stepper motor or another motor, and then plus Arduino. Ask in the forum if you can't find anything. Send me a mail if you have done research and are still in doubt. I will upload these slides and probably also the video to CampusNet. And yeah, I think that's it.
Are we gonna do the?
Yeah, we are going. I forgot that. Sorry. We're going to do some live coding examples on the projector in maybe 5-7 minutes. So you can maybe do whatever while I just set up this stuff. And yeah, so see you in 5 or 7 minutes.
So, before moving to that, it's just clear that if you have some ideas about what you want to use or how you want to use, try to put it on the CampusNet or send to JC. He says no hard deadline, but if you do it in next week, you will be able to get some answer when we are here in 2 weeks after the, what is it called, fall break, right? So try to be as quick as possible with your concepts, with your brainstorming, and if you need assistance at that period, send JC or me or put your files on CampusNet so we have an idea about what you want to do. And now we have a break of 10 minutes, and after 10 minutes, JC will project his screen on the projector and do some coding with the Arduino, so you can see step by step how you write an Arduino code and what happens when you change certain parameters and so on. Okay, see you in 10 minutes.